This
And
conference will now be recorded.
And the agenda for today is to go through, just have an introduction. There's several new participants to this work stream, so I want to make sure that we're all on the same page as we move forward. I want to also talk about the update of what was going on for those that couldn't attend the OCP summit, and that will be a short update, and then have a contribution discussion as well. And last time we initiated discussions on manifold and talking about different design options, continue on that and talking about operational parameters. What are the type of flow rates and pressure that we will experience or expecting to experience in rack manifolds? And since there are several new participants here as well, I wanted to revisit the leakage mitigation discussion as well. So with that, and since we have many new participants as well, I would like everyone to just do a quick introduction of your name and who you're working for. That I would appreciate that. So anyway, I can start. So my name is Jessica Goldbrand, and I work for Intel, and I'm leading the cold plate workstream. And hopefully we can move down the list here. Maybe we can just follow the list. Yep.
It's Nigel from Isotope, calling in from a train, so if I do lose you a few times, apologies for the inconvenience.
Thank you.
This is Dustin Dimitri with IBM, work on our liquid-cooled hardware products.
Thank you.
Cam Turner, Cool IT Systems.
This is Anthony Mistretto with Parker Hannafin on the quick coupler side.
Thank you.
Cam Turner, Cool IT Systems, the director of the Hyperscale Business Unit.
Thank you.
It's John Fernandez, thermal engineer from Facebook, working on the hardware engineering side.
Thanks.
This is Nicolas Monnier speaking with Stubly Corporation, working on the quick disconnects.
Thanks.
This is Nantis from Win Summer Solution Team.
Thank you.
Hello, this is Sebastian Varela, and I'm with Cool IT Systems as one of their mechanical engineers.
Thanks.
It's Mike Thompson from nVent, and I do management software for air conditioners and row coolers, rear door coolers, and pretty much anything data center related.
Thanks.
Hello, this is Ray from Win Summer Team.
Thank you.
Hello, this is Jiong, thermal engineer from Win Company.
Thank you. Anyone that hasn't introduced themselves? Beth, did you introduce yourself?
Hey, sorry, I think I was on mute there. Yeah, this is Beth Langer with Colder Products Company. We work on quick disconnect couplings.
Thank you. Anyone else we missed? Okay, thank you. Appreciate that. So starting then, the purpose really of the cold plate workstream is to, and you can find this information, it's all on the wiki page as well, is generate an open specification and supporting documents, focusing on standardization and definition of critical interfaces, operational parameters, and environmental conditions that enable interoperability of non-proprietary multi-vendor supply chain of liquid-cooled solutions. And the near-term focus is really to create specification that focuses on the ACS and TCS fluid loop. So it's basically the secondary loop that we're talking about, and it's from the CDU to the rack manifold, through that to the IT equipment, through cold plates and so on and back. So that's the secondary loop that we're focusing on. And in that we have focus on connectors, welded materials, rack manifold spec, and or keep out definitions for rack. So we're a work stream that is under the rack and power work stream, rack and power work stream, and it's advanced cooling solutions. So there's 3 different advanced cooling solution work streams going on. One is the cold plate one here, another one is immersion, and then the third one is the rear door heat exchanger. And in this work stream, the ongoing discussions right now is on last time we're talking about manifold locations, had an initial discussion on that, and on leakage mitigation as well. However, as I said, I will revisit the leakage mitigation and hope to have a larger discussion on that as well, and the importance thereof, if the community is finding it important enough, right, for leakage mitigation. So we're starting then with the update from the OCP summit. So on the advanced cooling solution workshop, there were 3 different presentations given under the cold plate work stream. And the first one is liquid cooling trends and requirements for rack and servers. That was given by Microsoft, by Sam and Brandon. The second one was direct contact liquid cooling performance on a Project Olympus server. That was given by Cam Turner from Cool IT. And the third one was ecosystem enabling of liquid cooling ingredients. That was given by myself and Mark. And these presentations, for those that were not able to attend, these presentations were recorded, and they can be found. I gave the webpage here where you can find them, and slides either are or will become available. If they have been submitted, they have also been posted on the webpage, so you can go back and look at the information that was shared there. So with that, really, I want to continue into any updates or comments at this point regarding the presentations at OCP. No? No feedback? Okay. With that, though, I want to go into contribution and have a contribution discussion as well, because in that, so me and Mark, we presented from Intel, right? And we were saying what we are contributing to OCP. So I want to be clear here in the work stream as well that is communicated. And Intel is really contributing then a welded materials list and supplier info and cooling fluid names that are compatible with that list. So we're currently doing testing of propylene glycol fluid. It's globally available, and it comes from 2 different suppliers. And the 2 fluids that we have selected is propylene glycol, 25% glycol content and 55%. The 55% is for storage and shipping, and the 25% is for operational fluid.
Yeah, okay. Can I ask a question on this? Actually,
yes.
After your presentation, this question came to me.
Yes.
So I understand the 2 fluids and the purpose of the 2 fluids. Are you advocating that a system would ship filled with a propylene glycol 55 fluid, and then somehow in the field you would then convert that over to a propylene glycol 25 fluid? Or
you
would
replace it in that case? Yeah, if you would have to ship it charged, the idea is to ship it with, if you need to fill or meet the requirement of -40.
Right.
If you don't need to meet that requirement, if PG25 is giving you enough freezing protection, right? Of course, it would be preferable to ship with that.
Right, but so I guess the question then is the case where you need the 55 in order to be able to ship it. So you ship the system with the 55, you get it to the data center. Are you expecting people then to convert it over to 25 or to operate with the 55?
No, to flush it out and replace it with 25.
So then is part of your contribution going to be some type of fill and drain system or tool or methodology to do that? Because I think that's critical if that's going to be what the
that's in the plans.
Okay.
Thank you for clarifying that. Yeah, it's in the plans of determined methodology for that, but I cannot give you a timeline on that right now.
Okay.
When that will be ready. That was all. Yeah. And what is also important, and most of the time, really, I think that you can get away with the PG25. Right? It's just if you're shipping to specific, really cold climates, we're actually doing some shipping tests as well, and measuring temperature in different locations during the shipping, in order to see how stringent really the -40 requirement is. And
is this
I want
something?
Yep.
Apologies. Is this something that will be published soon as a part of this work stream? The results of that testing?
The result of the shipping testing, or of the the fluid testing?
Both, right? I'm assuming the fluids currently have a temperature spec, right? Stating that you can only go down to a certain level. But the shipping test, I assume, would be a verification of that in a system, right?
Yes, it would be. I have to bring that back to make sure that it's something. I don't see any issues why we wouldn't be able to share that. I just have to bring it back and verify.
Okay, that would be great. Thank you.
Yeah. And just to make sure as well that these fluids, it's globally available. It's a propylene glycol, but it's from 2 different suppliers, and they're not interchangeable. Just want to make sure that I'm clear with that. So we actually, to give you a little bit of background, we started down the path of looking at if we could instead develop a fluid in order to make sure that it could be, again, globally available and common and interchangeable, and be provided by different suppliers. But walking down that path, just the cost and the timeline that would take, we went away from that approach, and we instead went with fluids that are already globally available instead. It doesn't mean that you, of course, can't go down the other path. It's just, the cost and timeline that is associated with that. And at this time at the OCP as well, I shared a wetted materials list, and it includes elastomers, plastics, and metals. We're currently testing for different bracing materials, and as we learn more and evaluate those test results that we get, we will add those on as well. And within the next month or two, I hope to be able to also provide the information regarding which fluid suppliers that we have been working with and what the fluid names are as well. And again, that's just for propylene glycol, right? So that's what we have been focusing on in order to enable the ecosystem for liquid cooling ingredients. And with that, I'm really want to bring up a call of action here. If there's any other participants on this call that has similar information regarding water with additives, for example, or with dielectric fluids. If there is any other information out there that you would be willing to contribute to OCP. Again, OCP is not promoting a specific fluid, but is open to use any type of fluid. And I wanted to check for the information that is out there and willingness to contribute to OCP.
So Jessica, this is Dustin.
Yep.
I'm not sure about contributing to OCP, but so IBM does have a very comprehensive water quality spec that's publicly available on our site for all of our water systems. So we use a water plus a corrosion inhibitor package.
Mm-hmm. Mm-hmm.
So that's all available. I could get the link. It's publicly available. So another reference that could be used if needed.
That would be good. And I have to check also. Maybe Michael will know here with OCP just because documents. I mean, at least we can reference it for sure. It's just as you were saying, we have to see with potential contribution then, right? But it's definitely a public reference. Okay, that would be good.
Public reference. I'm not sure about a contribution, but I can.
Yep.
Add back.
Yep, I can check in with the OCP as well, right? In order what that potentially would mean. But that's good, a public reference for that. Do you have any additional, except from the spec itself, any type of testing that has been done that potentially can be shared, or?
That I don't know about. I mean, we have testing. I don't know if it can be shared, but I'd have to look into what data we have and whether we can share that. So.
Okay, that would be awesome if you could, though, to make sure that we're, again, we want to make sure that we're enabling liquid cooling, right, and giving everyone multiple options. I think is better than giving them one, right?
Yep.
Thanks. Anyone else has any comments on that?
That's Cam. I'll talk to our supplier and see if they're willing to contribute there. It's a PG25 mixture, but it's also globally available. So yeah, I'll talk to them and see what they're willing to do.
Okay. Thank you. Thank you. And then we were also presenting, and we have also presented the universal quick disconnect design in this meeting. Previously, we also presented that at OCP. So we're contributing the interchangeability of the UQD to OCP, and the UQD is expected to be available here, or planned to be available in Q2. And the next step for that is really to do in the same way a universal blind mate design that is in the works. So that's just giving the kind of the big picture of that. But also I was curious that during the OCP meeting, especially on the demo floor, there was a lot of different racks and manifolds and fluid connectors and cold plates and so on shown there. So I really would like to know and have clarification of what, if anything, of that has been contributed to OCP, or if it will be contributed to OCP. Okay, doesn't seem that that's the case. So please, if not in this meeting, but you can also reach me outside of this meeting time and let me know if there's designs that you want to contribute. So please let me know about that. Again, if not in this meeting, outside of this. My contact information is available through the OCP web pages. Okay. And then last time we talked about the manifold locations, really, and discussed a few different options. And we had Steve Mills from Facebook on the call as well to talk about the rack design and potential positions for really locations of the manifold. And we came up with that it's beneficial to have manifold options for both the front side of the rack as well as the back side of the rack. And during the OCP meeting, Steve also presented the rack, the V3 proposal, and it's an early concept and it's still open for feedback. And part of what we're going to do here in the cold plate workstream is really to be able to provide input to the rack and power group of where we want to see, for example, the manifolds. So this is what Steve presented of just showcasing rear-mounted blind mate manifold in the back on the if you're facing it from the front, it's on the right-hand side. And due to that, it was based upon feedback that he had received from Microsoft, that Microsoft had PDU on the other side. But it's nothing that has been set. It's an initial estimate, and it's really of getting this rack design and potential manifold location out early in order to receive feedback from the larger community. And the option here from the front of showing it on the left-hand side, again, that's just an option. It could be left, it could be right, it could be both. So that's where they are regarding the rack design at this point. And we're looking at developing a few different concepts and hopefully come into the next meeting in 2 weeks to discuss that here. Because, of course, where you place the manifold will have a large impact to the IT equipment as well, of where you're placing it, how you need to route the cooling loop inside of the IT equipment as well. So that definitely, we need a larger discussion on that. And with that, the rack manifold, the operating parameters, I started putting some data together. So this is really data just found online, looking at different CDU suppliers and CDU options, and talking about then the 3 different CDU options that we have is in-rack CDU, in-row CDU, and virtual CDU. So it's more of creating those, what are the operational parameters that the manifold may experience from the different CDU options that are possible for the installation. And in-rack, and again, I'm not I'm not the expert on this, right? I'm sure that the participants here in the cold plate workstream have much greater insight into this. So see it as an initial draft, and please come with comments, and we change it as well. What I have found so far, really, for in-rack CDUs, are looking at cooling power of 40 to 80 kilowatts with max flow rates of 70 to 80 liters per minute, with nominal flow rate of around 50 liters per minute, with a max pressure of 30 psi. And the size of the NRAC CDU is about, depending upon who the supplier or manufacturer is, it's about 4 to 5 U's. And potentially here, how many would you see in a rack? And I put in 1 to 2 units per rack. Any input? Any on these assumptions?
I mean, I think the assumptions are fine. If we're trying, I guess this is a manifold discussion, not a CDU discussion. So
exactly.
But, generally I dislike putting cooling power numbers out there without specifying things like temperatures, and it can be very deceiving.
Oh gosh, yeah, yes.
Particularly when you're trying to also relate that to the flow rate, right? So that's my only comment.
Okay, so potentially just taking this out. I just put it in due to of getting a feel for what is it that you potentially want to cool in a rack. How many kilowatts, and in that case, how many units for the in-rack CDU versus in-row CDU. Potentially, how many racks would you be interested in cooling? It at least helps with giving an estimate for that. So that's how I was using it. But yeah, I'm good with not putting that in too.
How about adding typical inlet and outlet water temperatures? Or actually coolant temperatures.
Yeah, I shouldn't say water. You're right. Typical. Is that something that you have information about?
I would imagine that the CDU manufacturers and cold plate manufacturers would have all of that, and there'd be some bounds on that, on what you would use for the flexible hose and what you've got for materials inside of the fluid couplings, and what you've got for, well, your whole wetted materials there is going to somewhat bound that, isn't it?
Mm-hmm. So that would be reaching out to CDU suppliers in order to provide some of that data.
Yeah, I think we would maybe want to steer away from typical and just give the kind of min-max. I mean, obviously min is your dew point, which is completely dependent on your facility. But max, I think there's a lot of validity in that for sure. What's your max return? Max pressure you can handle on the primary side. And to the cooling power, potentially that should be discussed in like an approach temperature.
Yeah, the interesting part there is I see different definitions for approach temperatures.
100%. Yeah, you'd have to define the metrology of what we're all referring to.
Okay, so replace with approach temperatures instead of cooling power. And any other feedback if to do max outlet?
So I mean,
cooling fluid temperatures, or
that would depend on your primary site, right?
Yes.
So
depends upon your cooling temperature. It's
Yeah, it depends on whether you want to go all the way to W4 and then take the approach temperatures and then determine how much delta T across the coolant loop in the IT gear itself, right? And you may come up with, with a maximum outlet temperature based on that.
But is the maximum outlet temperature here of what the CDU components can deal with?
Sorry, I thought this was the discussion for the manifold and the impact to
Yeah.
what it
Oh,
would do.
sorry. Yes. We get into, sorry. Yeah, talking about the CDUs as well, right? In order to get the operating ranges for the
Sure,
manifold. Yes.
yeah, that would represent a sort of return temperature from the rack
Yeah.
itself. Yeah.
Yeah, Jessica, I mean, one comment, you know, and I don't know there's a right way or a wrong way to do this, but so, I mean, when I think about the manifold, I generally think about this the other way, right? The manifold is sized to meet the capacity of the IT equipment. So in my view, you kind of have to start with the IT equipment cooling demand, and the CDUs on the other side it just needs to meet that demand. But I mean, the manifold needs to be designed to support the flow rate requirements of the IT equipment.
Right.
And
yep.
you know,
Yes.
so when I think of manifold design, I'm not thinking of things like temperatures. I'm thinking of things like velocities. So how big does the manifold have to be? How many quick disconnect fittings do I have to put onto it? Things like that.
Yes, I'm thinking pressure and flow rate, right?
But I guess the point being, you know, in my view, and again, just maybe another way to think about this, like when I go about designing a manifold, I don't think about the CDU at all. I think about the IT equipment that the CDU needs to support. And that's how I design my manifold. And then the CDU is an afterthought. It's now I need to find a CDU that can provide enough flow rate. But I need to build the manifold and size the manifold in order to meet the demand of the IT equipment, not the demand of the CDU.
Yes.
So again, it's just a different way of thinking about it. But
sure, I'm not saying that one is you know, better than the other, right? What I'm trying to look at here is potentially max operational parameters, right? I know I can put quite a lot of power into a rack, right? But it might not be representative, right, of a more common liquid cooled solution. That's why I was starting off with going down the rack or going down the line of looking at CDUs instead, and what CDUs can potentially provide.
okay, that's it. Yeah.
Right. Yeah. So it's, I mean, I hear you as well, and we should definitely do that. But you know, since there's no magic number, this is, you know, a little bit what to struggle with as well. There's no magic number for when liquid cooling will be when you have to move to liquid cooling per se, right? But it depends upon really your TCO model. When does it make sense for you, for your particular installation, to go to liquid cooling? When does that become more cost effective, right? And since it's not, I can't put a specific kilowatt per rack when that always is gonna be the case, right? And that's why I went down again the CDU route. But if that's, you know, if that's open for discussion, is that something that that anyone, you know, would like to propose, of saying that you know, this is when we should start looking at liquid cooling if we start reaching blah number of kilowatts per rack? I just think that that's so specific for the particular installation.
I think that's outside the scope of this group. I guess all I was saying, all I was getting at is, in my view, the manifold has to be designed the manifold has to be designed with the IT equipment cooling solution in mind, not the data center cooling solution in mind. It's very different, right? We call out 40 kilowatts or 80 kilowatts, but from an IT design perspective, flow rates and things like that don't necessarily scale with power. So it's very different if you're putting a 5 kilowatt 1U node in there versus a 2 kilowatt 1U node. At the end of the day, you can still come up with 40 kilowatts at the rack level, but the node level requirements and the manifold design is really dependent on the IT equipment design.
Yes, yes. And I mean, the piping, the manifold, the IT cooling loop will totally depend upon how much power that you put into that 1U.
Right, exactly. And I guess that's what, when you brought up, some specs around the manifold, that's where my head was at. So again, let's continue. I think this is good amount of work here, so let's just continue.
And yeah, so for in-row CDU then, so we can again we can replace cooling power per CDU to approach temperature. What I found was 150 to 400 kilowatt CDUs where max flow rates per CDU it was in the range of 230 to 360 liters per minute. And again, this comes with a maximum pressure of around 70 psi. The size of it is a rack, and potentially what I put in here, potentially be able to cool 8 to 20 racks. So from that, then being able to say the nominal flow rate from that per rack would be about 45 liters per minute. And the last one is virtual CDU. So virtual CDU is when you have the primary fluid has high enough quality that you'll be able to basically distribute that directly into the IT equipment. But I also wanted to check here. So I'm expecting that most of the applications will be either in-rack CDU or in-row CDU. Is there anyone on the call that is using virtual CDUs? Is that something that we should consider here, or is it something that we potentially take off the table? Any feedback on that? No feedback? Okay. Then I will keep it for now. And it's really very similar to the in-row, what the numbers that I put down here for virtual CDUs, similar to what I have for in-row CDU, except higher pressure. And I shouldn't say that, but it's also higher flow rate. Again, assuming 8 to 20 racks for a virtual CDU.
Sorry, I have a question on this virtual CDU. Is the assumption here that please correct me if I'm wrong, if I misunderstood, but the primary side pumping system will basically serve as the CDU and the fluid will be directed to the racks directly?
Yeah, through a so-called virtual CDU. So you would control the flow to the racks directly from the primary side. So there's not a secondary fluid and primary fluid. There's only one.
Oh, okay. So it'll just be some sort of flow modulation system, but there's no plate heat exchanger or some heat exchange in the middle.
No. Yeah.
Okay. In that case, I have two questions. One is, then it means that the propylene glycol solution would have to be used to exhaust the heat to the environment eventually. And the other is that pressure rating would then be dependent on the number of stories that the data center has, right? Like if it's a multi-story data center, then it'll probably have to be, all the equipment would have to be rated for a much higher pressure value.
Yes.
Yeah. Someone please correct me if I'm wrong, but that's at least seems to be my understanding by reading stuff online.
Right, and I think one comment on that, as the 80 psi number, I'm sure is the correct number. But again, for the manifold's not going to see 80 psi, right? That's the facility level pump pressure output probably. The manifold's not going to see that, right? And I think that's important from a testing perspective and a burst pressure perspective, right? Is our pressure thing has to be in line with that. So I mean, if we go and say that our manifold has to maintain or be specified to withstand 3x or 5x or whatever the number is this week of 80 psi, that's very different than 30 psi, right? So just need to make sure that's clear.
Yeah, but maybe we're keeping that out then. Maybe we're not, because I mean it's facility dependent. Maybe we're having too big of a scope if we're including that as well, because we're making assumptions here, right?
Right. Again, and I think come back to my previous comment is if you looked at this at the rack level, right? What's the pressure that's actually needed to move the fluid through a manifold that serves a certain amount of pieces of IT equipment? That's the pressure we really need. We don't care about really what the pressure output of the CDU is. We care about what the manifold pressure is, right? So, so yeah.
Yep. Okay, I will update. And then in the past or the last 14 minutes here, I just wanted to get into again the leakage mitigation. So of course we're assuming that all designs are according to a robust leak prevention, really. But otherwise, for participants on this call, is leakage detection and intervention a concern? And if it is, at what level is it a concern? Because there's many different ways to deal with, for example, detection, right? So is detection at the CDU level, is that good enough, or a rack level, or chassis level, or node level? The more you go into finer and finer details, going from CDU to node, of course, that will also come at an added cost. And then some of the intervention options, right? Of if you're doing something that is you getting notified and getting a manual intervention, is that good enough for leakage interventions, or do you want a safe shutdown of your equipment, of your IT equipment, or do you need a safe shutdown of your IT equipment as well as fluid depressurizing, right? So you're stopping the leak, or automatic CDU intervention, right? So of course, if you're going from a safe shutdown to safe shutdown and fluid intervention and shutting the fluid off, that's going to have a higher impact and be more costly than if you're doing something of getting a notification manual intervention. So I wanted to get some feedback from the participants here on the call of to what degree is leakage detection and intervention a concern. Is it a concern? Does it happen
value, with regards to whether it happens or not, I'm not sure, but I believe that there'll be value in scoping out what these solutions would look like at different levels, right?
Jessica, it's Nigel. I think that,
yep,
definitely the customers are going to be concerned about this. Whichever site operation team is managing it, they'll want to know this information for their own operational uptime support, right? So I think definitely we need to cover a number of areas around leak detection and also proposals around intervention. And that can also mean that we can look at concurrent maintenance as an option in consideration as well. And I think we should be looking at that.
Okay. Thank you. Any other? So Nigel, your suggestion is to come up with proposals for leakage detection, and then a few suggestions maybe of interventions. Correct me if I'm
Yes,
wrong here.
no, I think that we should call out a few leak detection options that can be considered. I think the way you've described it at those levels is a good layout. And then I think we should call out and look into some parallels within other areas of operational teams and how they maintain both preventative as well as planned maintenance schedules and be able to provide that part. If we're going to grow this category and it's going to be deployed en masse, these are the kind of questions and answers that the customers will definitely be looking at us, and certainly will want to have some kind of direction, and this sort of paper should absolutely be covering that.
Okay. I mean, I think it's of importance, but I can't say to what degree, right? To really to what degree do customers require this in general?
So I apologize for the background noise, but so that's why I'm limiting my inputs. But certainly, in any customer, when you're speaking to them, one of the critical points is that within the top 5 questions that they're asking is, and that's one of the fears around moving into the white space and taking a water-based liquid into the white space is, how do I prevent it from leaking? It's one of the biggest factors we have to consider.
Thank you. Any other input? Dustin, in your experience, what's your feel of
I
it?
mean, in my experience, and I think of detection and intervention as different. I mean, I know from my own experience, you need to have things like secondary containment and stuff. I don't think of that as detection and intervention. We don't have any active leak detection in our systems that we've shipped for, I don't know, 40 years or something. That's not to say that our clients don't have leak detection at other levels, just we don't do it within our server drawers, but that's not to say they don't have stuff at the data center level and things like that. So I would agree with Nigel. I think it's important. It's certainly something that customers are going to ask for, right? And I think we should at least have something to talk about how it could be done. So, yeah.
Thank you. Anyone else? Any input on that? Okay, so I will add that to the list then of what to consider. And again, we can, around each of these topics, maybe we're creating smaller work groups as well to discuss this in more detail in order to determine at what level we want to really put this type of proposal for different detection mechanisms and potential intervention options as well. Okay, great. So any other comments, questions, opens? No?
I have
Okay.
I have a quick one.
Yes.
With regards to disconnects, is there a plan to spec sort of a rack level or a manifold level connection or disconnect spec?
It's we're still in the discussions of that. The initial question really when we brought up the UQD, the universal QD, was really if we could apply that type of design in other places in the data center, right? So, for example, to rack to CDU or additional places, and there's potential for doing that. We don't, and that's something that I should say, is something that we currently revisiting as well. So it's not currently on the plan, but we're revisiting and looking into it.
Okay, thank you.
Anything else? Any questions, opens? Nope. Okay. Well, thank you so much, and talk to you in 2 weeks.
Thank you.
Thank you, Jessica.
Thanks.
Thank you.
Bye.